You guys want to do alcohols?
You want to drink it? By that time. It's Thursday, baby.
Yes?
Get all this in.
You guys want to do alcohols?
Sure.
We're not going home, okay? Over my dead body or
The Heat play tonight. Huh?
Huh?
The Heat. What time the Heat play?
Yeah, the Heat play tonight. I'm not watching the game.
I know, I usually want to eat.
33 hours. 33 hours. I'm on a 36. It wasn't 33. No, it was how much? I don't even know how much it was. It was like 2-3 days. Okay. And then I almost died. Seriously, I got an asthma attack and a panic attack and all kinds of attacks. Alcohols are those that look like what?
With the OH. Yeah.
With an OH, okay?
Yeah.
Talk about physical properties. Alcohols make hydrogen bonds, yes? Hydrogen bonds. So alcohols have a higher boiling point than alkanes with similar molecular weight. Yes, because of an increase in what? What type of forces?
No, it's
Hydrogen.
Smack you
no.
right now.
They saying the whole every bond.
Yeah, you said all intermolecular
I thought I
forces.
wrote
Because of an increase in
Dipole
dipole
forces,
forces, specifically hydrogen bonds.
You said higher boiling point than what?
Huh?
You said higher boiling point.
Corresponding molecular weight alkane.
So when is it blood than dispersion? Forces? None.
Okay, hold a second, Luis. Let me finish talking.
Who's this?
You?
Me?
So which one has a higher boiling point, this one or this one?
The top one.
This one has a higher boiling point. So the higher the molecular weight, the higher the boiling point. Is it because of hydrogen bonds?
No.
No. As the molecular weight starts increasing, what happens is the London
Becomes
dispersion
nullified.
forces start increasing. Not only do they have hydrogen bonds, but now they have more London dispersion forces and the molecular weight increases. I mean the boiling point increases. So this has a higher boiling point. And I talked about this exhaustingly in 1046, yes?
Yep.
So much that I don't feel like talking about this in this class. I'm tired of this. Okay. Now, alcohols can be primary. What type of alcohol is that?
Primary.
Primary. Alcohols can be
Secondary.
secondary because this carbon here has how many carbons
Two.
attached to it? Another 2. The carbon where the OH is
One.
has how many carbons attached to it? 1. And if it is
Tertiary.
like this is tertiary. Yes or no?
Yes.
What type of alcohol is this?
Primary. Primary, right?
It's primary.
It's neither primary, secondary, tertiary. It's something different, guys. You don't see it, is it?
It's vanilla.
This is a
right?
vinyl
Yes.
alcohol. Anything on this carbon directly on it, on any double bond is called
You said it
vinyl.
too.
Yes?
You kind of retracted it.
I didn't retract it. I know it's very good.
So,
You know, I like to keep my cool.
yes, like the radicals. What's so funny?
Oh, man.
It's white. Okay.
Okay.
White.
Okay, guys, is that it?
Yeah, vinyl. Vinyl. Vinyl alcohol. And this is called vinyl
Chloride.
chloride. Outstanding. Okay. All right, what else? confused, yes? Let's do it.
Ahead of you.
Okay, we're gonna have a test, okay? Not next week, but the week after that. Okay? And this test, what size do you expect this test to be?
Same like the last one?
Medium.
It's gonna have these radicals.
Yeah.
It's gonna have
SN1, SN2.
SN1,
E1,
SN2, E1, and E2, and it's gonna have
Alcohols.
alcohols.
Okay.
Okay,
Alright.
which I will finish next week, which I'm going to send you this sheet to do. And I'm going to start the next chapter next week too. Okay? Yes?
Yes, sir.
Alrighty.
Don't underestimate the test.
Repeat that one more time.
Like we did last time.
It's on video.
Watch the video. Give it 1,000 hits, baby.
Okay? Look here. So what is going to happen if I have an alcohol and I add an acid to it, particularly a strong acid? What is going to happen?
Becomes water.
Become water. You are right. Okay? You are right. It's not that easy, right? It's eventually going to become water. Is that what you expect out of alcohol when you drink? That it becomes water? That's what you say? You're an alcoholic, aren't you? So, here it is. That is going to attack that. That's going to leave. And this is going to be a protonated alcohol. As a leaving group, OH minus is not very good. Yes?
Yeah.
OH
Yeah, you
minus
gotta get
is a
water.
strong base, not a good leaving group.
Uh-huh.
Yes? But once it's protonated, now it has a positive charge, and if it leaves,
It's
it
gonna
is going to
become
leave
water.
us what?
Water.
As water.
Yeah.
And water is a good leaving group.
Correct.
Okay? Now, if that happens to leave, whether it's leaving, and when things leave, what are they? What type of reactions are they when they leave? They could be substitutions, or they could be eliminations too, yes? But this one in particular, with the Br minus that is hanging around,
Substitute.
what is the Br minus going to do? This
Gonna
is a
attack that
primary
carbon.
alcohol,
Alcohol,
which
yeah.
has been protonated,
Uh-huh.
and it is going to attack it there, and the water is going to leave.
True, true.
And what this is going to give you is the alkyl halide. You must be kidding. In the last chapter, from an alkyl halide, we got an alcohol when we added water, yes? And now we added this HBr, and it gives you an alkyl halide. It's crazy. Isn't it? I mean, tell me the truth. Last chapter, we had this, yes? And we added water, and it gave us this. Yes or no? And now we add this to the alcohol, and it gives us the alkyl halide. I know you love this. I can tell you love it. What's happening?
This.
Okay, let me give you some.
Oh my god. I'm so tired.
What's the product to that? Let's say,
Does that say 135?
Oh, wait. What it was? 0504?
I'm not playing either, it is 135. It's not BS, no, absolutely not.
So it looks like the B.
I understand it looks like a BS, but it's not a BS, it's a 135.
Gotta make sure.
What's the product?
DMS, so. Is it S? SN2? I don't know.
Let's say it's an isotope of iodine. This is not 135, That one is isotope 135. What's the product? Hello? The product is yes? Yes. That's the product. Whether you substitute it for the same or you don't substitute it for the same, still the same thing. Okay? What type of reaction was this? SN2. And what type of reaction is this one?
Elimination?
This one is still SN2.
SN2. Yeah.
Okay? It's for an alcohol. Last time we had an alkyl halide, but now this is not a good leaving group, but we protonated it.
Yeah.
We made it a good leaving group, and then something else attacked it.
And it's done a concerted step, right? So.
Yeah, if it's an SN2, yeah.
When it's not a good leaving group, how to go to the process?
When it's not a good leaving group, if it's OH, yeah.
You gotta go to church, right?
Oh my God.
Provide the product.
Oh my God. Did you just say that?
Right after this last about
Product. Okay. This one, whatever, and this one, that's up.
Yes, I didn't talk about this from the, I talked about this in the lab, yes? Which one has a higher boiling point, when it's branched or when it's not branched?
it's
Not
not.
branched.
Which one has a higher boiling point from those two?
The top one, the top one.
It's not right, that's right. Has a lower.
Higher. The top one.
In 1046, you learned that what? Branching does what to the boiling point?
Decreases.
Increases the boiling point, yes?
Yep.
Because it has less surface area of contact.
Yeah. And solubility too. Which one is more soluble?
Are we doing something or not?
Yeah.
You guys look like daydreaming. You guys want to go home already?
Yeah.
Wait, the product for that, is I, right? With the iodine. Yeah, right.
Obviously.
So, what happens when you have an alcohol and you add a strong acid like this? That is going to be protonated and is going to be made into a better leaving group.
And then
And what mechanism do you expect this to have gone through?
SN1.
that's SN1.
Yeah, the mechanism for this is after you protonate this, probably this leaves,
Yeah.
so form a carbocation here, and then that will attack
It's like
it,
the carbocation.
Yeah.
and that's what you're gonna get.
Oh no, wait, hold on. Let me draw it for you.
What else, guys?
Do that.
Questions? You don't have any questions?
No.
You sure?
Yeah. I'm tired.
No what? No. So alcohols with strong acids, gonna give you substitution once again, yeah.
Alcohols with strong acids.
There is a possibility of rearrangements. There is a possibility that this thing might eliminate. There's all kinds of possibilities, okay? But we are doing substitutions right now.
Endless
Were we
possibilities.
supposed to have a quiz today?
No.
You want to have one right now?
No. We are
Oh, last class?
Saturated.
Yeah, me.
What?
Well, I've been here since 8 o'clock in the morning. Professor. And I've been taking classes.
I have been away since then.
Oh. I'm exhausted.
I hear you say that in all the videos.
On Tuesdays, yes. Two on Thursdays.
Alcohols with metals.
Okay? So, you have an alcohol, and you add to this sodium metal. Okay? And what is going to happen is the sodium metal is going to start giving electrons to this. And what you are going to form is this CH3O with a minus charge. Yes? Hello?
Mm-hmm. CH3O minus.
With the sodium next to it, and H2.
Na plus H2.
So the sodium.
Where that H2 come
Ooh, stomach.
from here. Okay? You don't like this balancing? Is that what you want?
So the sodium substituted with one of the H's, with the H.
The sodium is giving electrons to everybody. Yes? Isn't this reaction like, maybe not. I did this 1025? Whatever, guys. The sodium is going to give electrons to the oxygen and then the hydrogen, and it's going to form hydrogen gas. That's what happens when you add metals. When you add a metal to HCl, okay, you add a metal to HCl, what you get is sodium chloride and H2, reaction that you learned in 1025. Okay, that's what metals do. Anyway, what can this be used for?
Buffer?
It could be used as a nucleophile, it could be used as a base. That is how you make it. If you add any metal to this, it will make the metal alkoxide. Okay? Another way of making that is if you add to this sodium hydride. And what is this sodium hydride? What is sodium hydride? NaH.
Strong base.
It's like this. What is it?
A base.
It's a base. It's going to pull that proton off, and it's going to give you, once again, that stuff. What's the sodium? An H2. Okay?
Well, that H minus is a strong.
Yes, the H minus is a strong base, yes?
Yep.
It is a strong base. To do a rearrangement. What? Huh?
off today.
Me?
Yeah.
Off? As in what way?
Not all here.
Yeah. Could be the case.
Has everyone signed this? Yeah.
See?
We sign it.
Oh gosh.
Everybody signed this? On 12. Did you guys sign this on 12? Or is some of, like, look, either half the class is signing for next week, or half the class didn't sign for today. What happened? Half the class signed for next week? Have we met already 12 times?
We didn't sign it.
No, I know, that's why. If we didn't sign for test day, and the semester has 16 weeks,
And we have 4 left. We should be as well.
there are still weeks that you guys have signed that I didn't give them this to sign. That's okay, you can sign up to week 16 already, okay? Next time. Next time. Okay? Okay, provide the product for that.
See how I wrote it here and I didn't write it?
It's gonna be a shit.
Yeah.
We have to listen.
Methyl.
It's not a metal shift. It's a hydro shift.
It's a hydride.
Yeah.
Hydride.
Yeah, it's a hydro shift. It's not a metal. You can't shift the metal because if you shift it, it's gonna
That'd be the whole thing.
Yeah, it's a
Yeah.
hydro shift. Great.
So, what's gonna happen? So this is going to eliminate this. And let's say that forms that carbocation, yes?
Uh-huh.
Secondary, let's say that is the carbocation that is formed. What's going to happen?
Hydration.
There might be some type of
The
shift, yes?
A rearrangement, yeah.
What shift is it going to be? It's going to be a rearrangement every time we have a carbon.
Axon.
And you see something like this around it. It's going to be either a methyl shift or a
Or
hydrogen.
hydride shift.
What's going on here?
Smoke break.
You gotta go, you gotta go. You don't see me going. I'm not like La Vista here. Okay, let's do both of them, see the difference. I did not put the VR. I wanted you to think before you did things. So, I'm giving you the opportunity here to think twice.
Because, yeah, the first thing it does was goes here. And then eventually with your attachment there.
Put attached there, but that's not the only story.
This one will be.
Okay, so what's going to happen is
Yeah.
you are going to have
The top is high.
this
Yep.
here again. Does this look like anything you did before?
Yeah, we just did something like that.
I think so. I'm not sure, but I think so. So what is going to happen is, once again, there is a formation of
Carbon cation.
carbocation, which has
Rearrangement.
rearrangement. And what can I move something here?
Yeah, the methyl.
If I move, if there's a methyl shift
Here
here,
you'll have a tertiary carbocation.
if there's a methyl shift, the methyl will move here. And now the carbocation will be here. And let's say that the Br attacked here, you will have this product. And if it attacked here, you will have that product, yes?
Can you put it on any of those?
Yeah, you can put it
What?
You can put it in an explainer, so it doesn't matter where you put it.
Professor,
Yeah.
why would the methyl shift doesn't automatically happen? It doesn't happen all the time.
Automatically,
I mean, does it happen all the time?
it happens most of the time, yeah. How much it happens, it's besides the point.
Like,
Here is
if
the
it-
here is the
doesn't happen-
carbocation, yes?
Yeah.
If the Br attacks this, you will get this product
Without the shift.
without the shift.
Okay.
And if it shifts, and it does shift, then you get this product. The point is not whether this happens 100% of the time, or 99% of the time, or 5% of the time. The point is that you get a shift, and one that the possibility is that you didn't get a shift, yes? And here, what do you get? If you move the methyl here, what have you done?
The same thing.
Nothing. It would look like this, nothing.
Yeah.
That's precisely the point, nothing. So what moves there is
The
The hydrogen.
a hydrogen. Yes? From here or from here? Oh, from here maybe, yes? A hydrogen from here?
No.
No? Not. Why not?
Because it's, yeah, it's a primary.
Because it'll give you a primary carbocation, yes?
Yeah.
So the one that moves is there. So what do we call this?
A hydride shift.
Hydride shift. And if the hydride shift occurs, what you have is carbocation here, and then the product will be with a Br here, or with a Br there. Okay?
Which we need to go to hydride sheet. Is the
One without the hydride shift, one with the hydride shift. Okay? This thing with the PBr3, give you a BR. And this thing with the SOCl2, thionyl chloride, is gonna give you Cl there. Both of those reactions are SN2 reactions. When you add the PBr3 or the SOCl2, you are making the OH a better leaving group. As a result of that, this leaving group is on a primary alcohol or on a primary carbon. And what it's going to do is SN2. Hello?
Yeah, SN2 is going
And the
primary.
mechanism for this would be the same as we did before.
Substitution. How do you guys feel about not having a summer for the first time of your life?
Having a what?
About not having a summer for the first time in your
Oh,
life. How do you
summer.
feel about that?
I haven't had a summer in a long time.
Outstanding. You haven't had a summer in a long time? Really? Since middle school? Wow. Outstanding.
I don't know, you might not want to, SN2, this is SN2.
Provided.
These are some of the SN2 reactions.
Do you guys want to learn these mechanisms?
Maybe next time there.
We're not gonna have a life in summer.
Yeah, it's an SN2 mechanism.
I like the stuff
That would be inversion of
You
that.
like this stuff better than what?
The previous.
No, I like the regular same.
From the previous.
Oh, you did not like alkenes and
No, not
alkynes?
that I didn't like them, I like these better.
Yes.
Yeah, these are
These are
shorter.
only four, there's only four of them.
What, you're gonna like hydroboration better than this mechanism?
It's gonna be inversion of whatever.
Stop complaining. You need an injection of some type.
Yeah, I do.
Guys, what's the product?
Inversion
The wedge,
of configuration.
dash.
How do you like that?
Yes.
Because, and you have to know this, you have to know that whenever you use this stuff, what you are going to get is
Inversion.
SN2, inversion of configuration. Okay? What is this? You say, Karen?
Just because it was SN2, but
I just looked up.
it's secondary.
Inversion.
Okay, next reaction, we'll do this with the sulfonyl chloride. You want- Yeah,
So
what?
it's a secondary reaction, and because of the, what do you call that?
Yeah, the SOCl2, thionyl chloride.
That's, SN2, get those to the SN2. That's what I think about
In case you don't put the dash,
What?
you're gonna take out point.
If what?
So don't put the dash.
If you don't put the dash?
You're gonna give it points.
Yeah, of course, half points I give you.
Oh.
How many of these questions we have?
How many of which type of questions? Have one of that, one of that, one of that, like that. One of all. Guys, any mistakes?
Wait, so if it's, never mind.
Guys, who expects a question like this on the test?
Everyone.
Are you gonna in the
You
future show us
expect one like this on the test?
Everyone.
One like that?
Of course.
Don't play. Don't play.
Everything you taught us.
I could if you wanted to.
when you do things like this?
Didn't you hear what I said?
What process?
This thing is gonna make this a better leaving group.
Yes.
This is going to attack
There's
that.
only 4 things.
There's a BR minus that's going to attack this, and that's it. This is going to attack this sulfur. Chlorine is going to leave, better leaving group, and attack it as a layer.
Okay, so what about everything else?
I'm gonna drive next week. I don't wanna do this anymore, okay? We're done
Thank
for
you,
today.
Professor.